So I'm just wondering if you can help us get our head around what type of like hardware and resources you need to work with LLMs.
Yeah, you bring up an interesting fact, the notebooks. So I do still use notebooks, by the way, a lot, even pandas. I mean, pandas is an old hat by now because it's been around for such a long time, but it is still relevant. I was just using it the other day to format my data set for the LLM, like classification fine-tuning data set. Yeah, like you said, there are limitations now because Jupyter notebooks or yeah, back then IPython notebooks, but let's say Jupyter notebooks, you can't really even train, I would say, most LLMs. Simple ones, yes, the small ones, but the problem is, for example, you can't trivially use the more advanced multi-GPU processing paradigms. You can do some data parallelism there, but because the way the forking and multiprocessing works, you can't really use, like tensor parallelism, fully sharded data parallelism in notebooks on multiple GPUs. So that's
Mm.
already ruling out notebooks, right? As a platform. It's more like it's useful for prototyping, but then for the real training, that would be just a paradigm shift where you go more into the engineering away from, like the toy examples almost. But yeah, so there are multiple, platforms because yeah, one limitation is usually how much RAM you have, GPU RAM, or how many GPUs you have. That's usually nowadays the bottleneck, and that is also why the meme or the saying on Twitter and LinkedIn is like the GPU poor thing, where people don't, but where it's everything is bound by how many GPUs you have and this type of stuff. And multiple platforms, of course. I mean, there's still Google Colab you could use for prototyping using a single GPU and trying things out. The problem though is with that, yeah, I think it's limited to one GPU. So you can't really do multi-GPU training. And I think I mean, depends on your tier, but after some time, the computation quits, like the runtime is exceeded or something, so you can like infinitely run something. And then, yeah, usually LLM training takes sometimes days or weeks. That would not be a good platform because then also, yeah, that would just not work. AWS and GCP and Azure, these are usually the platforms where you can, yeah, rent your instances to train things. But that I did that also at university and stuff. The problem there is you have to set up your environment every time, and it's expensive because you rent your GPU or your machine with a GPU, you set it up, you spend a lot of time configuring things, and you pay for that basically, right?
Mm.
GPU costs while you just do trivial things. And one option, okay, a little plug here, but at Lightning AI, we have also a platform where you can use GPUs, but the nice thing is you can basically run Visual Studio Code, Jupyter notebooks, and you can flexibly switch between CPUs and GPUs. So I can do my coding like I would do on my normal computer in Visual Studio Code or Jupyter notebooks on a CPU, which is free if you use the first CPU. And then, unless I'm running code, I don't waste my money there. And then once I'm ready to train my LLM, I can just switch to multi-GPU machine or multi-GPU option. Basically, you just add on your GPUs and you don't have to install anything again. It's persistent because in Google Colab, it's usually even when I prototype, I upload my files. I do some debugging, and then, oh, now I want to use my GPU, and then it deletes your whole environment. You have to install the requirements again, and it's kind of it's kind of a hassle. So we kind of developed also the Lightning AI Studio at work for ourselves as researchers, so that we can actually effectively solve problems. But yeah, also a lot of people find them useful. So that is another option if people are interested in fine tuning or training LLMs, where that might be something they find useful. But yeah, there are several options. I also still use my personal computer sometimes for small problems. So there is, I would say, no right or wrong solution, but there are tools where you can do things more effectively if you need GPUs, which is usually the bottleneck for LLM training.
Amazing. And I've actually put a link, I'll put it in the show notes and I put it in the chat I shared the GitHub for your LLMs from scratch book. I've actually shared the link to the setup instructions
Mm-hmm,
where you
mm-hmm,
go through a lot of these ways to do it as well.
mm-hmm.
Speaking of running things locally, also, hopefully we'll get to this, but on the weekend you trained, or maybe just before the weekend, fine-tuned a spam classifier on a GPT model on your laptop, right? So we
Mm-hmm.
hopefully we'll get to that example.
I can show that, yeah. So this is something where I trained a small GPT model, like for educational purposes, but it does perform pretty well. It can classify spam with I was like 96% accuracy
Mm,
on a balanced data set, and so yeah, you can train that model on. I did it on my MacBook Air, so it worked in I think it was like 6 minutes, but yeah, on a GPU, if you had a GPU for that, it would only take 30 seconds. So it is still like a magnitude of 20-fold, where it's 20-fold faster to do it on your on a GPU compared to a laptop. But it is possible. So it's actually maybe a great intro to LLMs, to fine-tune LLMs, to try it out first on a simple LLM. And what's nice about that, what I like about GPT-2 is um, you can then load the pre-trained weights from OpenAI into it, and you because they shared them. Of course, there are also weights for other LLMs available, but what's nice is it's small. It fits onto a single GPU, and you can do all kinds of things with it. But they also have a 1.5 billion version where you can scale it up, where it would only run on a GPU then. The other thing is also all the other LLMs are derived from that architecture. So
mm,
I will probably make some materials sometime to convert GPT to Llama and Mistral and Phi. Actually, we have a project, open source project called LitGPT, where it's exactly that, where we have one library that implements all kinds of neural networks: Mistral, Phi, Llama 3, Llama 2, stable LM, I think we have 30 LLMs implemented there, and they all share the base architecture. There are only slight variations. And this was also actually for me or for my colleagues a great learning experience to basically understand more about architecture choices, because you can change a few things, and then you actually it's great to play with LLMs that have been pre-trained. And the reason is it's kind of like a self check, because when you implement the architecture yourself, you have to get it exactly right. Otherwise, you won't be able to load the weights, because the tensor dimensions won't match basically.
mhm,
So it will complain, oh, your tensor is too big or too small, or something didn't is not compatible. So it's kind of like a great way to learn to code LLMs by using an architecture that exists and then coding it yourself and then loading existing weights into it. And so, but even then, if you get the architecture right and you load or let's say you think you get it right, you load the weights into it, and you then run the LLM, you can quickly see whether you did everything correctly or not. Because if you make a tiny mistake, then immediately you will see the LLM generates like gibberish. So you have to get
mm,
it exactly right. I remember when we were implementing that was the Google Gemma architecture. It was quite funny because they had a lot of different implementations out there. I think there was like a JAX, Keras, and a PyTorch one and stuff like that. So we tried to make it so load the weights into our LitGPT framework, and then it loaded fine, but somehow the model generated gibberish. And then we did like find out why. It was, I think it was like an offset of the RMS norm had a +1 offset, but like a small thing like adding +1 makes
yeah.
a whole difference. And it sounds trivial, but this is actually a great learning exercise, because it's kind of like helping you to understand what they did, because you really have to get it right. And these are things that are usually not mentioned in the papers. So by coding those things, you kind of like even learn more than you would just learn from reading the papers. Basically, it's really actually a great and fun exercise. Fun if you at some point find the solution. Otherwise, it's kind of frustrating. But it is still a good, I think, fun thing to do. Yeah.